Hello and welcome to another video. Recently I've been looking into how virtualenvs work behind the scenes so that I can better replicate the behavior in a tool I'm writing. And so I figured I would share the knowledge that I've found on this. And it's fairly straightforward for Posix-like platforms, but Windows, there's a lot to uncover. Anyway, let's jump into it. Okay, so in order to show what's going on here, we're going to make a virtualenv, and first I'm going to explain the Posix behavior. Fortunately, the Posix behavior is very easy to understand, but the Windows behavior is not. I'm using virtualenv, venv, the built-in venv module will create the same things, it just happens to be slower. If we look at the structure of this, -L3, yeah, well, let's actually do -L2 because we don't need any other stuff. Okay, so you'll notice inside this virtualenv, there is a bin directory. This is where all of the scripts are going to get installed. And then there's a lib directory. This contains your site packages and nothing else. So if we look at venv lib Python 3.10, you'll see that there's just site packages. Whereas normally in a Python install, you'll see all of the standard library there, like this. Now you might ask, how do we get the standard library, 1, and then 2, how do we still have the site packages? And the way this works on Posix-like platforms is the actual Python binary, you'll notice it's a different color here. The actual Python binary is a symlink. Let's do not the prefixed one. The actual Python binary is a symlink to the real Python binary at your installation of Python. So this is the global Python. And when you start Python, so when we do venv bin python, you'll see that we get a sys.executable, which still points inside of our virtualenv. We get a sys.prefix that is our virtualenv. But if we look at sys.base prefix, this will point to our original installation here. So what happens is when Python starts up and it notices that it's from a symlink, it sets up this particular organization of prefixes here. It also sets sys.path. Oh, we already have sys imported, sys.path, to include the site packages of our virtualenv. This is where dependencies get installed. Okay, that's all fine and great. If we install a tool into that, so pip install astpretty, this will write things into site packages. So if we look at venv bin site packages, we see astpretty.py. It will also write things into the bin directory of your virtualenv, such as this astpretty script right here, if it has an executable. If it doesn't have an executable, obviously we won't do that. If we look at the first line of venv bin astpretty, this is the shebang. This is how on Posix-like platforms it finds the executable for this file. And this file points directly to the Python of the virtualenv. And since we already know the Python of the virtualenv can pick up both the standard library and the site packages, everything will be available when we run this executable. And let's see. Dev standard in 1+1. Sure. Yeah, anyway. So all of those things will be available. And so the answer to how do virtualenvs work on Posix-like platforms is 2 things. Symlinks, to make the executable available, a little bit of startup magic, which is part of that symlink part to do the syspath, and then shebangs. So shebangs and shimlinks. Symlinks. So that's how virtualenvs work on Posix-likes. This includes Linux as well as Mac OS, although if you're dealing with Python 2, the story is completely different, but we're going to ignore Python 2 for this. Only talk about modern things today. And you'll note that on Windows, sometimes the symlinks are available, but usually not necessarily. And there's no such thing as shebangs on Windows. Windows just doesn't execute in that manner. It executes based on the file extension and still path, but it executes based on the file extension. So you don't have the same choices on Windows. We can't use the shebang trick, and we kind of can use symlinks, but there's other limitations like Windows. There's some like limitation with Windows and symlinks where it doesn't resolve the original executable path properly. Anyway, symlinks are out and shebangs are out. So we need a completely different solution for Windows. Now, I'm going to show you the solution for Windows. So now we're on a Windows machine here. And I've actually created a virtualenv before this because it takes a long time. So we're going to be looking at the structure of this venv 310 here. Let's see, do I have tree here? I don't. Okay, so VM310 has a little bit different of a setup here. You'll see that it's capitalized lib and capitalized scripts. If we look inside the lib directory, it goes straight to site packages, so you don't have a versioned prefix there, so it's a little bit different of a directory structure than Python. And you'll notice that inside the scripts directory, it looks very similar to how Python is set up. Of course, all of the executables are .exe or .bat or, well, I guess they're all .exe because this is just deactivate and activate. You'll notice that there is a python.exe here, and if we look at that python.exe, scripts python.exe, you'll notice that it is a actual file. So it is not a symlink. This is a real executable that lives here. And another thing that you'll notice about this is this file here is 260K, but if we look at the actual executable in my base prefix that I built this virtualenv from, python.exe, the actual executable is 100 kilobytes. So this executable that's inside the virtualenv is different than the one that is actually shipped here, which is a little strange. You'll also notice that there's this python.w.exe. I'm going to ignore this for most of this. The TLDR of python.w is this is for windowed applications. That's what the W, I believe, stands for. So things that would open up a graphical thing and not show up in the terminal. So if you want to double click on something and get a graphical thing. On other platforms, there's no difference between graphical executables and not. Like they're just the same thing. Windows, they're a little bit special so that a command prompt doesn't show up in the background. But ignoring all that. Okay, so we know that this is not a symlink. We know that this is not the original Python executable. What the heck is this thing? So what this executable actually does is basically two things. The first is it tries to locate the original Python executable, and it does that using this pyvm.cfg file that also appears inside of virtualenvs. This file is also there on Posix, but I don't think it actually gets used for anything. Oh, we can't use bang dollar because it's not bash. You'll see that this pyvm.cfg, actually let's look at the 310 one since that's what we started with. You'll notice this includes a couple of details here. One is this, oh, I guess technically on Posix it will use this flag, but it has a home. This points to where the original executable came from, so that's how I was able to say, you know, Python 310 python.exe. I know I created it from there, but this is the little marker to go back to there, and that's how it finds the original Python. So basically, this little executable here, well, it's bigger than the original one, but this VM scripts python.exe. What this thing does? Oh, we should have done 310. Sorry, I should have been consistent here. What this executable does is it finds this pyvm.cfg file. It finds this home line here, so it knows where this original executable comes from. Then it sets an environment variable. We actually can't see it because it gets deleted as part of the startup, I think. pyvm launcher is the environment variable. Yeah, so it's gone now. We can actually find it by looking at the process tree structure for this. So running this executable runs the original executable with a special environment variable. This is so that Python can find the virtualenv. Then it uses this virtualenv to add the right things to sys.path, then deletes this from the environment so that it doesn't poison other processes. And so basically anytime you run python.exe in a virtualenv, you're actually running two processes. If you're familiar with Windows, running processes is one of the most expensive things you can do. So anytime you run something in a virtualenv, you're adding a little bit of overhead to it. And if we find this process, let's see, procs equals proc4 proc in, is it process iter? I don't know, I just remember. If python in proc.name, that gives us two processes. Yes, so I don't know. Let's see, we have start time. Oh, they have the same start time. Let's see if we can find that pyvm config there. pyvm launcher. Yeah, so you can see here, this is the process that spawned, or this is the actual Python executable. This is that little shim executable, and it set pyvenv launcher to this value here. That way, this the actual Python interpreter could pick up, oh, okay, this is the executable I started with. I need to go 2 directories up, and then this will be the virtualenv that I put onto sys.path. So if we look at sys.path here, you'll see we get the site packages on sys.path. We also see that same sys.prefix and sys.base prefix that we see in Posix, but of course it's set up in a different way. Okay, so that's the first part of this. This is how does the Python executable happen. Now we also have to talk about how do other executables work, because you'll notice inside our virtualenv we have, for instance, I should use 310 because that's where the other one we're going to use is. You'll notice that we have these other executables, this babby.exe, which is my text editor. And so if we run that one, it's actually going to do a different thing entirely. So you'll see it still starts up, it still works, so it is doing that sys prefix stuff in the same way, and it's also passing back to that original executable, but it actually needs to do a little bit more work to make that happen as well. So if we cd into workspace, I'm going to look at the process tree for this. We actually started 3 processes to make that happen, which is a little unfortunate. And again, anytime you start a process on Windows, you're going to take a bunch of overhead. But if we look at psutil again, I wonder if I can press up to get the other one. Nope, it's gone. Procs equals proc for proc in psutil dot proc process iter if babby in proc dot name. Okay, so we should have the babby process here. We should only have one process, right? Okay, cool. If we look at proc0.children, you'll see that this spawned a python.exe. And if we look at the, let's see, can we look at the executable? Is the actual child1, oh, child1 0. I want to look at the executable. It should have called the python.exe inside the virtual environment. .exe. Oh, I had it right. Why didn't it work? I didn't call it. Yeah, so you'll see that it called the Python inside the executable. And then this has children itself. So this calls back into the base Python. This is basically the same Python that we saw earlier, the same shim thing. Oops, let's not do this. And so you'll see that there's another process here. And if we look at the executable of that one, that's the base one. So basically, if we go over here, when I ran babby.exe, this called into python.exe in the virtualenv. And then this called into python.exe at my system. So at C Python 310. So starting any executable inside a virtual environment starts 3 processes. Now, I didn't explain what's actually going on here. So the neat thing about this executable here is it's actually an omni executable, or not an omni executable. It's a it's a very special executable that finds itself and then reads data out of it. It is a zip app, actually. I did another video on this before. I will try and link that in the description, but it's basically a way to make an executable by appending data to it. It has a special structure. The structure basically looks like this. You have the normal executable code at the top of it. Then you have a special byte marker, which is 4 bytes. And this is basically what they use. Oh, does the end square bracket not work on my keyboard? Oh, that's weird. Cursors must not like the end square bracket. Anyway, we can't type the end square bracket. Then there is a shebang that is python.exe for this particular one. It could be pythonw.exe if it were a windowed application. And then finally, there's a zip file at the end of it. And this zip file contains, well, it can contain sort of anything, but this particular one contains /main.py, which essentially does from babby import main and then sys.exit main. It's essentially what it does. It's a little bit different than that, but you could think of it like that. And this actually isn't the right module path, but trust. So this is a special little shim executable. Basically, it opens itself. It tries to find this special little byte marker. Then it tries to find a shebang line after it to know what executable to replace itself with. Then it calls this. So it basically calls VM310 scripts python.exe, it passes itself along as the first argument, vm310 scripts babby.exe. And since this is a zip file, Python knows how to run zip files. It'll grab the contents of this and run it. Also, just to show you that it's a zip file, we do zip file, open. Oh, can you just pass it past to this? I don't remember. Scripts babby.exe. Invalid argument. You have to open it. I don't remember. Oh, raw string. Right. Backslashes. They have special behavior. Okay, so we have a zip file here, and if we look at name list, you'll see that it has that one main.py. If we do zipf.open main.py.read, you'll see that it has, essentially that script that I was talking about from babby.main, import main. And Python knows how to run zip apps, and so even after that process tree that we talked about up here, this process knows to run this executable as a zip, and it also knows, based on the pyvm launcher environment variable, that it needs to put the virtualenv on the path. A lot of complexity goes into making this work on Windows because there's no such thing as shebangs or symlinks. Well, we can't use symlinks. There's no such thing as shebangs, and symlinks are sort of useless on Windows. But anyway, that's how virtualenvs work. It's fairly complicated, but now I have figured it out, and hopefully this video documents it as well. Hopefully you found this useful. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.